So this week we're going to wrap up our discussion of sedimentary rocks and environments by focusing on rocks, and we'll also talk about how you can interpret those rocks back to the environment in which they originally formed. So we are going to be looking at and identifying sedimentary rocks in lab this week, and we'll also do a little exercise or a couple exercises where we interpret some sedimentary environments and then put those rock layers into context to kind of build a short, kind of simple story. Just as a reminder, here's the rock cycle. Our sediments come in the rock cycle part on this top part of the curve when rocks weather due to physical and chemical processes, which produces smaller and rounder pieces as well as clay minerals. Clay minerals are like little pieces of rock, but they're actually produced by chemical weathering, and then dissolved ions in solution. And the smaller the pieces and the clay minerals form our clastic sedimentary rocks, and the dissolved ions in solution and other things in the environment can result in our non-clastic or chemical and biochemical sedimentary rocks, as we will see. So we've been talking about different environments where sediments are deposited. So this is just kind of a quick review. We had these lovely drawings in the book, and then they kind of focused in. And the idea here is to think about all of these environments that we talked about and the different types of sediments that you can find in those environments. And not just that, but kind of how those sediments are layered upon each other, how they're mixed with each other. And you can see every one of these environments that we look at is a little bit different. And because it's a little bit different, we will end up with some different sediment deposits. They'll have some different characteristics that we can then recognize once those are turned into rocks. So the processes are active in many, many different places. Pretty much everywhere you go on the face of the earth, you can see these processes. And the environments where things are deposited also tell us a little bit about the climate as well. So one of the cool things we can do when we look at sedimentary rocks is they're not only a record of the kind of the physical environment, like was it a river or was it a coastal area, but you also get information on the wind direction and was it a cold environment or a warm environment, because those things will potentially leave clues in the sediments as well. And so we have a whole bunch of clues that we can look at that help us determine the environment of deposition. So we'll be using EOD as an abbreviation for that. Things like how well sorted are the sediments? Are they poorly sorted or are they well sorted? How round are they? And a whole variety of sedimentary structures, from ripples and mud cracks to what are called graded beds and cross beds. And cross beds, you might remember, we looked at last week when we were talking about deposits left by dunes. And we saw some mud cracks when we were talking about deserts, so when things dry up. So lots and lots of clues that we have to look for. And I kind of made this slide up from one that I got from the book, but it makes you think. Sand and turns into sandstone, but think of all the environments where you can find sand. But it's not always the same, it's different. So the sand in a dune is not the same as the sand on a beach. And the sand in a river and a delta are not the same either. So each one of these has different characteristics that allow us to interpret that environment and deposition. So I left an extra slide in there. So as you go farther and farther away from the environment of where the sediments were originally formed, so that we would call that the source environment, and your environment of deposition could be very close to the source, in which case you would have something that is kind of angular and large and not very well sorted. And then as you get farther and farther from the source, you'll notice things get rounded off. They tend to get smaller, and they tend to be more well sorted. So those are, again, some of the clues, some of the things that we look for. The other thing that we can look for and look at are fossils, and fossils are evidence of past life. So I only have one fossil slide in here. There's some more information in your textbook, but you can see there's a variety of things that count as fossils. So in the upper right, you can see there are little hard parts from some kind of organism. In this case, it's an organism that we call a crinoid that lives in the ocean. So the hard parts are very commonly what we find: shells, bones, teeth. But also we can find things like trace fossils. The lower right-hand corner here shows some dinosaur footprints, and in fact, the footprints of several different types of dinosaurs. You'll notice there's different sizes and shapes and orientations of the toes. So those are what we call trace fossils. And then in the lower left, we have plant fossils. You can see some leaves, and that's soft material as well. So most commonly, we get hard parts. A little less commonly, we get trace fossils like footprints and things, or leaves. In order to do this, in order to preserve something as a fossil, there are a couple things that need to happen. It has to be an environment where it can get buried. So if you think about a tree falling in the woods outside of the college or in your yard, or let's say in the park, and it just lays there and it decays, it doesn't get buried, and over time it gets returned to the soil, and that will never leave a fossil. So you need to be in an environment where things are being deposited rather than eroded, and you also need typically to bury things fairly quickly, because the longer they sit there, the more likely they are to be scavenged and destroyed. So that quick burial in an environment of deposition, and it helps to have hard parts. Like I said, and you can see on the slide, we can find softer materials if the conditions are right. But it's a little more likely to find something if there are hard parts. You'll notice in the upper right-hand corner, those crinoid stem fragments are fragments. They're broken up. So whatever environment they were in was a little bit rough on the organism after it died. But because it had some hard parts, those are preserved. Soft parts usually get destroyed in the process. So, for example, with dinosaurs, we mostly find dinosaur bones. In a few cases, we can find some skin impressions and some other things. But mostly what we have from the dinosaurs are bones. So when you get softer materials preserved, that is something that is very much prized by paleontologists, which are people that study fossils. Another thing that should be mentioned is that fossils are a really good clue for environment of deposition. So if we find fish fossils, for example, that's a good indication that you're in the water, because that's where fish live. If you find these plant leaf fossils, there's a good indication that if you're not on the land, that you're pretty close to the land, because you've preserved something that lives on the land. Same thing with dinosaur footprints. There were marine dinosaurs, but they did not leave lovely footprints like this. So that's an indication of a land environment. So what happens? How do we turn sediments, including fossils, into sedimentary rocks? Well, we have to bury the sediment, and that is typically followed by some compaction because of the weight of the material that's on top, and cementation. So water percolating through these sediments can leave minerals behind, which will help cement and solidify the rock. Where this happens initially is the environment of deposition, but then afterwards it gets buried. And you can see in this series of drawings on the right-hand side that as sea level rises and falls, it will move environments of deposition, marine environments of deposition, across the landscape. And the same thing happens with other environments of deposition as well. The reason that they show marine here is because the easiest environments to preserve turn out to be the marine environments. Land environments, after you get some deposition, very often you can get some additional erosion. So if you think about the Illinois River and how it meanders, after it leaves a deposit of sand somewhere, there's an excellent chance that it will pick it up and move it again. So marine environments tend to cover larger areas, and if sea level is stable for a while, it'll leave a pretty thick deposit over a very large area, and subsequent deposition will then bury that and allow it to be turned into stone. So when we go to the lab this week, what we will do is we'll first need to classify the sedimentary rocks before we can name them. So you'll find in the table in your lab book the two groups. There are the clastic, which are also known as the detrital sediments. They're made of gravel, sand, silt, and clay. So it depends on what you're looking in. I believe the lab book calls them detrital, and your textbook goes with clastic, but they're essentially the same thing. And some common clastic sedimentary rocks are conglomerate and breccia, which are made of gravel and larger particles, sandstone, which is obviously made of sand, and shale and siltstone and mudstone, which are made of the finer materials. Then we have the group that we call the non-clastic sediments, or the non-clastic sedimentary rocks, and they're divided into a couple very broad groups, the chemical and the biochemical sediments. And the biochemical stuff is organic material. Here I've got some slightly different classifications because there are different ways to look at these. What you should know about these, and you'll find out when we discuss them in the lab, is that they are classified based on their mineral composition. So one really big group, in fact, the biggest group of sedimentary rocks are the carbonates. They are made of the mineral calcite, which is calcium carbonate. Typically, they're made of shells, which could be macroscopic, big enough to see, all the way down to microscopic, which is too small to see. So there are shells of all shapes and sizes in the ocean, and that's kind of the basis for most of our carbonate rock. Down in the lower right-hand corner, you can see evaporites. This includes things like salt and gypsum, but it can also include calcium carbonate. That can precipitate directly out of the water as well, and we'll see that on the next slide. And then in the lower left is purely organic carbon material in that case, and that is coal. So rocks formed by chemical reactions, they show here an evaporite deposit, which is in this case rock salt, but it could be gypsum, and there are some other minerals that deposit that way as well. And then they show a setting where you have hot water that's evaporating, and you can get some limestone out of that. In this case, it's called travertine limestone. So that's a non-organic limestone. But many times we have living organisms facilitating or making this deposition happen. And so you can see a coral on the left and a fossil limestone on the right. And you can see a little bit of a swamp on the left and some coal on the right. So we're going to wrap this discussion up and our workup this coming week with reading a sedimentary sequence. We always read from the bottom to the top because sediments are deposited one on top of the other. And what we can do is we can look at the sediments that make up that rock layer and interpret the environment of deposition. So that would be like a chapter in a book. And then we put the chapters in order, and we know the order goes from bottom to top. The exercise that we'll take a look at in the lab is on a 2-page spread in your textbook. And we'll probably do this, you'll probably be able to do this at home, and it ties into the last question on the exam. You look at the sedimentary rock layers, and remember we always go in order from bottom to top, and in this case you can see they describe some of those layers. They pull out some of the details here in your textbook, different types of sandstone and other types of sedimentary rocks. Some of the clues are the fossils that you might find, and this is what we call a representative rock column, which kind of puts everything into order. And you'll find this in the textbook at the end of chapter 7, and I will provide you guys with a worksheet in lab this week that you can complete.